So we need to move on, and we want a drilled and reamed hole M6 right through the middle. Just speed that up a touch. So we'll centre drill it first. A bit more glue. Let's have a look at that. A touch more. That'll do. I'll swap out the centre drill for my chuck. Take that away. Remove my drill chuck. And we're going to go with a 5mm to start. Look at that. So we're going to give it 5mm, and I think we'll go 5.8, something like that, for the reamer. That's the 5 through. And 5.8. Should do us. Keep going to it. Running about 850, something like that. Not going mad. Okay, that's that through. And next step, put those two drills away so I don't lose them, and see what we got in the way of 6mm reamers. So I had a little look through my collection of reamers, so various metric ones, a couple of odd imperial ones. And I did have this 6mm chucking reamer, and I know it's quite badly worn on the end. It does get back to size, you know, as you come away from the end. So as long as I go in fairly deep with this, we should be somewhere near. So let's just slow things up a bit here. 160 RPM, something like that. Again, be kind to it. Put a bit of gloop on it. Get somewhere near, there we are. And let's see how we do with this. It's only taking 0.2 of a millimetre out. As I say, normally I just have to break through the outside, the back edge with this, but I know the end of the reamer does have a bit of wear. So I'll probably go, oh, I'm losing a bit of torque there. Just speed it up a touch, just to give the motor a chance. There we are. Now it's got to the area where it's cutting better. And having experience of this particular reamer, I do know that to get a good cut, I do need to have to go quite far in. I think that should do me. Let's just try the dowel in there and find out. Let's get that reamer out of the way and switch her off. So I think we'll have a little chamfer on the leading edge, because it's this space that's going to bolt down onto the little dowel that sticks up from the bottom. So just a little bit of a chamfer on there, just to aid assembly. And we'll try a dowel in there. As I said, do have a 6mm dowel. it is tight. I think what I'm going to do is just give that a little tap, see how tight it actually is. I do have a Morse taper 6mm. I know this reamer's pretty good, cuts to size nicely. 1 to 2 sleeve, and I could always run this reamer through, no problem. So that's the 6mm dowel fitted into the plate. So at least I know I've got some means of turning it round and holding it on that 6mm dowel. We'll go from there. So I'm holding it 6mm dowel in the chuck, and I've tapped the dowel through so that it's just below surface. I will have to go a few more mil back when I face this right off, but I'm trying to give it as much meat in there as possible while I get rid of the worst of it, so to speak. So yeah, I mean, it's tight. It's a very snug fitting dowel. I did have to tap it in with my little tapper, and if I run it up, the area of the machine door already seems to be running absolutely true, so great news. So up with the lathe tool, and we'll skim that back to its final thickness of 8mm. So we'll just tickle down this top diameter. As I said, I'm not going mad on it because its drive is purely the friction of the dowel. And when I say it's a dowel, it's a hardened and ground, or case hardened ground M6 dowel. And it's about, I don't know how long this one is, 40mm long, something like that. Just taking off that little lip that I couldn't machine for fear of hitting the jaws. And that's that. And now I'll face off the little register that we were holding it on the other way round. I'll stop just shy of the centre, because I don't want to go hitting that dowel with the end of the lathe tool. As you can imagine, I've been very careful with this. I'll bring you back when we're somewhere near. I think I've had my life out of that tip, so I'm just going to change it. If you'll notice, I pulled it off the tool post, taking it out here on top of my headstock. If I were to drop that screw with all this swarf around, well, as you can imagine, we'd have a bit of fun looking for it. And having had that bit of fun in the past, I think I'm just looking at my tip that I have used all 3 corners. So we'll get a new tip, put it back in. But as I say, take it away from the lathe, or, you know, do it with a clean lathe, it wouldn't be a problem. But if you've got tiny screws in the end of your tip tool, when you drop it in the bed with all the swarf, yeah, you're wasting quarter of an hour of your life looking for the screw. So just pull it out, maybe put it on the bench, put it somewhere clean, so that if you drop the screw, you can find it easily. So I've been whittling away at this, just 0.1 at a time. And I'm looking for a finish thickness of 7.9, I think I'm going to go for, working clearance of 0.1. And that's measuring 8.03. So I want to put another 0.1 off it. And I'll just shave that little last bit out the bottom when I finish the thickness. I can always remove that with a drill bit at a later date. It's a 45-degree or blue chamfer on the top. Another bit more. And new tips make quite a difference. And we'll have another little measure. Eight mil on the nose. Another 0.1. should be about it. Okay. Seven 7.89, 7.89, 7.87. Okay, yeah, I think we're happy with that. I think we need a little bit larger flat on the top because we don't want a sharpish edge there. The flat that's on there is about 0.5 millimetre wide. I'd rather see a mil or so. So I'll just take a few little tickles over the top of this. Okay, that looks good. And now I've got a square corner on the top of here, so I'll just put my 45-degree tool up, which is hiding from me for a moment. Where are you? There you go. No, that's the one I just put down. There it is. And I'll bring that in there. And just put a little 45 on there. Do me. Well, we need to remove the bit in the middle, much as I can. I'll probably be able to just chase that in with my normal tool just to the bottom, and I'll break the edge with a file or something afterwards. So where are we? Remove the last bit. I don't want to hit the dowel with this nice new tip, so I'm going to leave like a tin foil thickness of steel down in the bottom here. I can literally take off with a deburring tool. It's actually got the point now where it's slipping. It's just there you go, it's gone. So there's the turned piece. And I have run the reamer back through the centre a bit further in just to give me a running fit on the dowel, because I don't want to have to hammer it down onto the existing plate with this little spigot underneath. So the next thing I need to do is get that little plate out from underneath my cross slide, and we'll match the two of them up and look at drilling and tapping the two holes to bolt them together. And started about here. Okay. So a slight design flaw. So I've had to machine a little square area on the front of the bottom of the taper. I had in my head that the plate that this sits on, when it was pulled up, was 0.1 below the top surface of the cross slide. It is actually 0.7. So when this taper came on top of the cross slide, it actually bottomed out on the taper on the cross slide before it got anywhere near the bottom plate. And I want this to be free running in the bottom plate. I only want it to tighten up when I force the brass plugs against the outside and sandwich it all together. So this will still be free to revolve in the bottom with the keep plate in the bottom. So I've had a machine, the hole is actually 32 diameter, and because this needs to go 0.7 below the surface, I've actually machined a diameter on there of 31.5, back 1 millimeter square. So I know that this will sit on top of the bottom plate when it's pulled right up, and it won't be tight, or that's the plan. But until we try it out, we won't know. So yeah, work it out as you go along. Nothing new there. I'll just break those edges, probably do that with a little file. So you can see the basic concept coming together now. That's the little disc. Let me just throw it in the scrap tray, no, in the swap tray. Yeah, this plate has 2 tapped holes, the original tapped holes. I'm not going to modify that. 6mm dowel in the centre, which sits on that 6mm. I'm going to drill and counterbore 2 holes in here to take some shorter Allen bolts and sandwich the 2 together, and it will still have the same, let's have a look, that plate will still have the same amount of float up and down as it has now, so that when you tighten the 2 screws, it pulls the plate up till the plate comes to a stop, and then pulls compound down onto it in exactly the same sort of method as it was doing before. So I'll pop that plate out, I'll spot through the 2 holes using the dowel to locate it, do one at a time, drill it, tap it, counterbore it, and we'll get those 2 sandwiched together. So I've just sandwiched the 2 together. I'm holding on the bottom one, top one's pressed down, the dowel's pressed in, and I'm going to spot through the existing 2 holes with the tapping drill, which is the 4.2, which should pass down through the middle of that M5. Just drill into that so far. In fact, there is no reason why I can't go right through with that, because I'm missing my parallel. Gently, gently. Okay. Bit more glue down the hole. We'll drill the other side. I think I better mark these as to which way round it goes, because I don't trust, I won't say don't trust, but I don't know whether they would match up at 180 or not, because I don't know how well these original 2 holes were drilled in relation to the pin. I would have thought so, because I haven't had a great problem wherever this plate is in putting the compound back on. But at least if I know which way round it was when it was drilled, I got a better chance of doing it the same way so they line up perfectly. So take the black plate off again and open them up, probably 5.1 clearance for the 5mm bolts, and then countersink the other side. So up with a 5.1 drill. Just tuck that in there. And drill out the holes clearance for the 5mm bolts. I'll go 5.1. I think we'll be fine with that. And the other one. So this being the underside, I think we'll just have a couple of little chamfers on those holes. So away with the 5.1, back in its rack so I don't lose it. And what have we got? I need a small chamfering bit. Well, that ought to do me. Apologise for me getting in the way all the time when I'm doing shots of me drilling. My drilling machine is actually in the corner, or pretty much in the corner of the workshop, and it makes it very difficult to get the camera in to give you the best angle. But I am trying to keep out of the way, I promise. So, and I've got to try and keep the vise this way so you can see what I'm doing, but I'm just going to put a little chamfer in here. One on that one, and one on that one. Happy days. So, flip it over, and we need some counterbores for the heads of my M5 bolts on this side. I'll just get rid of the swarf out of the vise. There we are. We'll sit that there. And we'll have a look at what we've got. Just tighten that vise up. There we go. It's actually really good vise, this. Even though it's all steel hardened, it's all ground square, it's a grinder's vise for surface grinding, that sort of thing. Toolmaker's vise, grinder's vise, whatever you want to call it. If I squeeze on that, I don't even have to actually put any force into the handle, and that's not going anywhere. I've been using this vise for 20 plus years and never really had anything come out of it, you know. So I'm always happy that it holds it flat and square. So let's have a look at what we're going to do to drill some counterbores to sink these heads in. So the heads of the bolts measure up at 8.25, and I have, because I've done this job before, an 8.5 drill and an 8.5 which has been ground flat bottom. So I'll start it off, get the point in and come into a slight amount of parallel, and then I'll finish them to depth with a flat bottom drill, which I'll gauge it just by dropping the bolts in until they're just below surface. So let's get on with that. So yeah, 8.5 drill, just get the parallel part of the drill started after the point. So and I think that drill is a little blunt. It'll do for what I want. I'm not going to do a whole video on how to sharpen drills. Let's see what it's like now. Much better. Okay, so that's got the parallel bit of the drill in. Could actually go a few mil deeper, say for flat bottom. So, out with my freshly sharpened 8mm drill, and let's just check. Yeah, that's fine. In with a flat bottom. So, let's just, where's my little brush? Where's my little brush? That'll do it. So I need to counterbore these in with a flat bottom until that is flush, and I've got plenty of meat, as you can see. At least I hope you can see. Quite important to line this up well before you start drilling. There we go. I need to sort myself out some sort of fixed stop for this machine. Crack more when I'm there. That will probably do me, just below surface. I'll do the same on the other one. Pretty much doing this by eye. Flush, just a bit below we want. So look at that. Below surface, below surface. I'll bring you in and let you have a better look at that. Don't know how well you can pick this up, but I've just done the counterbores with a flat bottom hole And as you can see, the bolts sit just below the surface, which will be fine. So a couple of chamfers on the top of there, and we'll be away. So we'll pull that. Right, so cleaned it all up. I did put a little matching pair of lines, so I've put those two together. Let's give it a squeeze, and some sort of success. At least I can see through the holes. So let's just try a couple of M5s in there. These are going to be way too long, these M5s, but at least I can measure how much too long by how much they stick out the back, and cut them off to suit. And there we are, just below surface with the 2 bolts. Wonderful. Next step is going to be to bore the hole in the bottom of the compound.